I'm Anil Kumar sharing with you test paper of my student. This is on calculus and vectors MCV for you. So we'll take up all questions from this test paper and discuss them one by one. So we'll talk about equation of lines. Question number 1 here is true or false question. You need to justify your answer. There are 3 parts to this. The first one here is for the given line r equals to r0 plus tu, t belongs to real numbers. When t equals to 0, the line would not have a defined direction. Is this statement true or false? You need to justify it. B is line L1 r equals to minus 2, 3 plus s times minus 1, 3. S belongs to real numbers. And the line L2, which is x equals to 3t plus 2, y equals to t minus 7, t belongs to r, are parallel. You need to justify whether it is true or false. C is the coordinates of a point on a line L1, x equals to 3, y equals to minus 2, z equals to minus 1, plus k, where k belongs to real numbers, are p 2, 1, minus 3. You can pause the video, take your time to answer these questions, and then look into my suggestions. Now let's discuss. The very first question here is, for the given lines, we are given a line r0 plus tu, right? So whenever we are given a line, so we know this is r0, a point somewhere on the line, right? So let's just make this, okay, like this, right? So let us say that r0 is this point, right? So that is the point. So that's the vector r0. So let me call this as r0 plus tu. So that's some direction vector, right? So from here we give you a direction. Now since what should I say? Since t could have all real numbers, so it's a scalar multiple in this direction u, right? So kind of that gives you a line like this, right? Some line. So basically, every value of t will give you some point on this line, and therefore it defines you a line. Do you see that? So that's how you define the line r. Now the question is, if t equals to 0, then what happens? If t equals to 0, then we are just talking about a point here. Is that okay? So this is the point. And now the question is, the line would not have a defined direction. So if you're just given r equals to, that means r0 plus it is 0 times u. Do you understand? So it is just r equals to r0. So we're talking about a point, right? Now any point in this space really does not give you any direction, right? So it's a point definitely on a line, but in R3, in space, right? So in space, and a point does not give you direction, right? So it does not have a defined direction. So we say yes, this statement is true for us. Do you see that? So this statement is true since it really represents the point here, and this point does not give you the direction, right? It may be on this line, but does not give you the direction. So that is true. Now the next statement here is, we are given this line where s could be all real numbers and the other line, and we are saying they are parallel. Is it true or false? Now for that you can find the direction vectors. So for the first one, we say, let's say m1, it is minus 1 and 3. And for m2, it is the x value is 3 here, right? So this is 3 here, so that gives you the direction part, and the y value is t, right? So it is actually, you could write this as t times 3, 1, right? So it is 3, 1, right? Since they are not scalar multiples, they are not parallel, right? Since they are not scalar multiples, 3 and 1, right? So since they are not scalar multiples, L1 is not parallel to L2, right? So this statement is false. The last statement here is the coordinates of a point on this line x equals to 3. So x equals to 3, y equals to minus 2, z equals to minus 1 plus k. K belongs to real number are 0.2, 1, minus 3. Well, this is definitely false, since any point on this line should be like 3, minus 2, and this value, right? Minus 1 plus k and minus 1 plus k. Do you see that? Where k could be any value. So minus 3, k could have a minus 2 as a value, but x and y values are fixed. They are 3 and minus 2. So this is also false. I hope that helps you to understand some concepts about this equation of line and help to solve your own test paper. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.